Hello, class, and welcome to Chapter 15. We're going to look at drawing conclusions to the bottom line of our research. So, when we're looking at an experiment, we talked about in the beginning of our chapters what it meant to be internally valid and externally valid, and what that means. So, an experiment is internally valid when the effects on the dependent variable are due to the independent variable. An internally valid experiment is free from confounding variables, which are variables that come in and interfere and actually is the one to have an impact on the dependent variable versus the actual independent variable that we are studying. So we must do a manipulation check. And a manipulation check evaluates how well the experimenter manipulated the experimental situation. A manipulation check determines whether subjects followed directions and were appropriately affected by our treatment so that we actually get a good indicator as to whether or not the independent variable had a significant impact on the dependent variable. So our subjects expect their data to be discarded if they guess the experimental hypothesis and don't volunteer this information to the experimenter, while the experimenters don't want to test additional subjects and may take subject reports at face value. So we want to make sure after we complete our research with our participants that we debrief the subjects after the experiment and convey that you want to know if they guessed the hypothesis, if they have questions, how do they feel after engaging in the research, and also taking the time to provide them with information in regards to their participation in regards to the research study um, at the very end after they've completed the process. So that during this time, providing incentives for guessing the hypothesis. So some of the mistakes that can produce threats to the internal validity, we may, as the researcher or experimenter, select the wrong statistical test using a t-test to analyze ordinal data when we would need nominal data or ratio or interval data for the t-test. And properly using a statistical test. So our calculations may be off. So calculating multiple t-tests at a time. Maybe we might need to upgrade to an f-test, a test that's more sophisticated to handle multiple IVs and DVs. We may be drawing the wrong conclusions from the test and reporting a p-value of 0.07 as a trend when we need to be looking at our 0.05 or 0.01 alpha level to indicate our um, significance level. An experiment is externally valid when its findings can be extended to the general population. So we've taken it from the inside of our study and tested it with everyone on the outside of the study. Our experiment must be internally valid, so have um, internal validity, and the experimental findings must be able to be replicated. So if we're able to do that, then we are satisfying the two requirements that's needed for external validity within our experiment. The findings can be extended to a larger group than the sample size if we have external validity, and generalizing across subjects is critical to the external validity and usefulness of experimental findings in the future. A study achieves research significance when its findings clarify or extend knowledge gained from previous studies and raise implications for broader theoretical issues in the future. We choose question novel findings. We should question novel findings when they contradict what prior research has said. So we want to make sure that we can successfully replicate our findings. And if we have something that's contradicting what past research has said, we would, as the experimenter, have the burden of proving um, why we see these claims of discrepancies in our research. And we may have that change, but we should be able to discuss the reasons that we believe this is the case. We want to generalize beyond the laboratory to increase the external validity of our findings. And we want to be able to control extraneous variables. Since extraneous variables are uncontrolled in the real world settings and operate in complex combinations, they can modify the influence of our individual variables. So the trade-off is going to be between the laboratory's more precise control of extraneous variables and the field experiment's greater realism and external validity. So Hansen 1980 found that more laboratory than field studies reported a positive correlation between reported attitudes and behaviors. We can confirm external validity. We can't confirm external validity until additional studies are completed in field settings to see whether or not the IV and the DV are indeed listing a significant difference between the two or a significant impact between the two, which would confirm external validity. Researchers can increase and verify the external validity of laboratory findings using aggregation, multivariate designs, non-reactive measurements, field experiments, as well as naturalistic observation. To define aggregation, aggregation is the grouping together and averaging of data to increase external validity. So, combining the results of an experiment with different subjects and methodologies increases the generality and external validity of our findings. We may also um, do a meta analysis to find logic in our data. You use this meta-analysis as a statistical analysis to combine and quantify data from many comparable experiments to calculate an average effect size. And a multivariate design studies multiple DVs. So if we have multiple IVs, we may use an ANOVA, but in a multivariate design, when we have multiple DVs, we may use what is called a MANOVA. So, for an example, a study of repetitive strain places a computer keyboard at different distances from the subject IV and measures the effect on three different muscle groups, which would be the three DVs, and we would use this multivariate design. Multivariate designs allow us to study the effect of an independent variable on a combination of dependent variables. These designs better stimulate the complexity of the world than univariate designs and provide a more detailed outlook on the impacts of the IV on the DV. We analyze multivariate experiments with a multivariate analysis of variance, that of which we know as MANOVA. So check for possible causes of non-significant outcomes like confounding variables, extraneous variables that increase within subjects' variability, weak manipulation of the IV, inconsistent or flawed procedures within our experiment, ceiling and floor effects within our experiment, and insufficient power within our experiment. If previous studies supported the hypothesis and ours did not, let's begin to look for differences in experimental design or sample. If there was no previous support and our design and execution were good, we may have to revise or possibly discard our hypothesis and start again to ensure that our data can be replicated and that it's observable and that we can indeed find use of our experimental research. And that concludes the end of this chapter.